Hi, let's continue building our skills with being able to integrate basic functions in the world of definite and indefinite integration. Remember, indefinite integration means I don't have numbers here. Definite means I do. And in either case, you need to be able to find the antiderivative to the function that we're integrating, the integrand. In this case, my integrand is 1 over x, and we seek to find a function whose derivative is 1 over x. Okay, so I happen to remember from the world of differentiation that dx of the natural log of the absolute value of x is equal to 1 over x. I remember that, and it's beyond the scope of this video to prove it for you. What that means is that this integral right here is equal to the natural log of the absolute value of x plus some constant c. So I feel like we can kind of just be done with this video at this point, in the sense that like the rule really is that simple. But there's a subtle point that's on the screen that I find that a lot of my students tend to forget it. And so I wanted to emphasize the following point, which is these absolute value symbols, right? Why do I have these absolute value symbols right here? I think the most succinct reason is to say that this thing right here is defined over all of the real numbers minus the origin, because we're not going to divide by 0. Whereas the function natural log of x, if I don't have absolute values right here, this part right here is defined for x greater than 0. Okay, so I've got an integrand that's defined for all of r minus the origin, which means my antiderivative also has to have domain. It has to have the same domain. Right? There's no way it can't possibly have the same domain. So how do I make this function right here defined for not just positive arguments, but all arguments, is by these absolute values right here. So it's really common to miss that. And I just wanted to super emphasize, especially when we go into u substitution, looking forward, that you remember to put your absolute values in, because they are a critical component of the integral of 1 over x. I have one other point to make. And that point is that this is the complement to the power rule. So the power rule says that the integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c, but only if n is not equal to -1, because otherwise we'd have x to the 0 and 0 here, and it would just be weird. So how do I handle this one that's missing from the power rule? Oh, check it out. This is the one right here that takes care of that case. The integral of x to the n dx is equal to the natural log of the absolute value of x if n is equal to -1. So I can erase this only if. I don't think the only is actually helping me in that particular instance right there. So if n is not equal to -1, then we get to use the power rule. But if n is equal to -1, then we have to use the natural log rule. So that's the basic rule for integration of 1 over x. Main point, absolute values. Don't forget your plus c's. Thank you so much for watching. I wish you all the best.